separation of substances. In the previous chapter, we learned to group things. In this chapter, we will study how to separate components of mixtures. Pure substances and mixtures. In nature, very few substances occur in their pure form. Most of these substances are found mixed with other substances. To obtain pure substances, we need to separate these mixtures. We use many methods to do this, depending on the difference in the properties of these substances. Pure substance. Any substance which is made up of only one kind of atoms or molecules is called a pure substance. For example, iron, silver, water and oxygen taken separately are pure substances. All elements and compounds are pure substances. Mixture. When two or more pure substances are mixed together in such a way that each component retains its properties, we call it a mixture. The amount of each component in a mixture can vary. For example, air is a mixture of many gases such as oxygen, carbon dioxide, and nitrogen. Dust particles and water vapors are also present in it. Sugar solution is a mixture of sugar and water. Brass is a mixture of copper and zinc. Need for separation. Perhaps you eat namkeens or mixtures containing groundnuts. Some of you who like groundnuts would pick them out and eat them first. Those of you who don't like them would still pick them out and keep them separately. In both the cases, you separate one component from a mixture to make it more suitable to your taste. A mixture may contain two or more substances in any ratio. These substances are called components of a mixture. We may need to separate components of a mixture for various reasons, such as to remove the undesirable or harmful components. For example, small pieces of stones and unwanted seed grains are removed from rice and pulses before cooking. Remove the impurities so as to obtain pure sample of a substance. Pure substances are needed in medicines, research, industries, and also in daily use. Separate useful components of a mixture so that each component can be properly used. For example, petrol, diesel, and kerosene are all useful components of crude petroleum and need to be separated. Methods of separation. The components of a mixture can be separated by simple physical methods. The choice of method is based on the differences in properties of the components of the mixture. To choose a suitable method for separation, we should find the property of the component to be separated, which is different from that of the other components. Separating solids from other solids. Handpicking. You must have noticed your mother picking up small pieces of stones, husk or chaff from rice and dal before cooking them. This method of cleaning food is called hand picking. It is used when the mixture contains solids of different colors, shapes, or sizes. It is used only when the component which has to be separated is present in a small quantity. Threshing. Suppose you have been given a bunch of grapes and a bundle of wheat stalk. How will you separate these stalks in both the cases? In the first case, it is easy for you to remove stalks from grapes. But in the second case, wheat seeds are so small that it is not easy to remove their stalks. Then how does a farmer separate these stalks from grain seeds? He uses a method called threshing. The farmer makes bundles of grain stalks and keeps them in the sun to dry up. After that, he beats them against a slab of stone to remove the grains. The process of removing grains from stalks is called threshing. Nowadays, threshing is done with the help of machines called threshers. Winnowing. The process of removing husk or chaff from grains by the action of wind is called winnowing. After threshing, farmers use this method to remove husk or chaff from grains. Winnowing is based on the property that grains are heavier than husk and hay. This method is used when there is a difference in weights of the components of a mixture. Here, heavier component, grains, and lighter component, husk or chaff, are separated by wind or by blowing air. For example, to separate wheat grains from husk and hay, farmers drop the mixture from a height. The lighter husk and hay are carried away by the wind and form a heap at a distance. The wheat grains, being heavier, fall almost vertically to form a separate heap. Sieving. You are well aware of sieving of flour to remove unwanted particles like husk or chaff from it. You might have also seen big slanting sieves at construction sites used to remove pebbles and stones from sand before it is mixed with cement. Are the pores of sieves in both the cases of equal size? Sieving is used when the size of particles of different components of a mixture is different. The choice of sieve depends upon the size of the particles to be separated. Care should be taken that the size of the pores of sieve should be larger than the smaller component, useful components, and smaller than the components that are need to be separated. Magnetic separation. This method is used to separate magnetic component of a mixture from non-magnetic components. When a strong magnet is passed over such a mixture, the magnetic components get stuck to the magnet, whereas the non-magnetic components are left behind. Iron objects can be collected from garbage by using a powerful magnet. Separating insoluble solids from liquids. Sedimentation and decantation. Sedimentation and decantation methods are used to separate insoluble solids from liquids. It is based on the difference in weights of different components. The process of settling down of heavier, insoluble particles is called sedimentation, and the particles that settle down form the sediment. The process of pouring the upper clear liquid into another container without disturbing the sediments is called decantation. You can also observe this process at home while washing dal, rice, etc. Your mother decants the upper layer of water which contains dust and other impurities. Rice or dal is left as sediment and is then cooked. Filtration. This method is also used for the separation of insoluble solid particles from a liquid. It is more suitable if the size of solid particles is very small. In this method, the mixture is allowed to pass through a filter. A filter is a medium with very fine pores. The insoluble solid particles retained by the filter are called residue, and the clear liquid collected is called the filtrate. Commonly used filters are a piece of muslin, mulmal cloth, and filter paper. A layer of cotton or a layer of sand can also be used as a filter. In filtration, the size of pores of the filter is very important. For effective filtration, the pores in the filter should be smaller than the size of the particles to be removed. Separating soluble solids from liquids. Evaporation and condensation. The process of conversion of a liquid into its vapor state is called evaporation. In nature, this process takes place slowly, but if we increase the temperature, the process of evaporation becomes faster. Evaporating sea water to get salt is one of the oldest ways of obtaining salt. This method is used for the separation of soluble solid particles from a liquid. A liquid component of a mixture can be separated by evaporating it, leaving the other component behind. The evaporated liquid can be recovered by collecting its vapor and cooling them. The process of conversion of vapor of a substance into its liquid state is called condensation. Condensation is opposite of evaporation. Evaporation followed by condensation is called distillation. Centrifugation. The particles which are very small and can easily pass through filter paper can be separated by churning or centrifugation. In this method, the mixture containing suspended particles is rotated at a high speed in a centrifuge machine. The denser particles settle down at the bottom of the container and the lighter ones stay at the top. This method is used to separate cream from milk, butter from curd, water from wet clothes, drying in washing machine. Separation of two immiscible liquids. Two immiscible liquids are separated by using a separating funnel. For example, oil and water are two liquids which are not miscible with each other. The mixture of oil and water can be separated by using a separating funnel. It is a device having a stopcock at its bottom. The mixture is taken in this funnel. Oil being lighter forms the upper layer. Water being denser forms the lower layer. When the stopcock is opened, the water layer flows out, leaving the oil layer behind. Separation of two miscible liquids. Fractional distillation. Two miscible liquids having different boiling points can be separated by fractional distillation. In this method, the mixture of miscible liquids is heated at different temperature to obtain different components. For example, when the mixture of water and alcohol is heated, the alcohol having lower boiling point evaporates, which is collected by condensation, and the water remains in the flask. Separation of components of a mixture by using a combination of various methods. Quite often, separation of the constituents or components of a mixture requires more than one method of separation. This is illustrated through few examples. Number 1. To separate the constituents of a mixture containing sugar, water and edible oil. We know that sugar is soluble in water and the solution of sugar in water is immiscible with oil. So we proceed as follows. Separate the mixture by using a separating funnel. Oil is left behind in the separating funnel and the solution of sugar in water is collected in a beaker. When we heat this solution, water evaporates and forms water vapor, which is collected in another beaker through condensation. Sugar is left behind as a white powder. Number 2. The mixture of rice, salt and iron fillings can be separated in two steps. Firstly, magnetic separation is carried out to remove the iron fillings. Next, rice and salt can be separated by sieving. Number 3. A mixture of sand, salt and water can be separated by using the techniques of filtration, evaporation and condensation. Can you tell which component will be removed in each step? Solution. A homogeneous mixture of two or more substances is called a solution. The substance which is present in smaller amount is called solute, and the substance present in larger amount is called solvent. Solute, small amount or quantity, plus solvent, large amount or quantity, gives solution. Solutions are of two types, saturated and unsaturated. Saturated solution, a solution in which no more solute can be dissolved at a fixed temperature, is called a saturated solution. Unsaturated solution, a solution in which some more solute can be dissolved at a fixed temperature, is called an unsaturated solution. Water, a universal solvent. Water can dissolve a large number of substances in it. Therefore, It is called a universal solvent. Importance of water. As water can dissolve a number of substances in it, this property of water is important for various purposes mentioned below. Water helps in digestion as food is soluble in water, which is absorbed by our body. It also regulates the temperature of our body. Many waste material produced in the body are dissolved in the water and excreted. It is essential for the growth of plants as they prepare food with the help of water in the soil. It helps in transportation of vitamins and minerals in our body as it is the major component of blood. It supports aquatic life as oxygen dissolved in water is used for breathing by aquatic animals. Carbon dioxide dissolved in water is used by aquatic plants for photosynthesis. In short, we can say that there would be no life without water. Science in the vicinity. People use RO water filter as it is not possible to get potable water from contaminated water through simple method of sedimentation and loading. The RO system use advanced filters which prevent contaminants to pass through. They also kill infection causing germs so that water becomes safe to consume.